So what is a chemical cell and what is the difference between chemical and electrolytic cell? The difference we'll discuss at the last, but first I'll explain you the working of a chemical cell. Chemical cell or a battery, basically group of cells together, we call that as a battery. So main thing is you understand the working of a cell, how it works. It convert chemical energy to electrical energy. So basically a chemical cell is a device which convert the chemical energy to electrical energy, or it can produce electricity. How it works? Working. So working of a chemical cell actually it consists of two metals with different reactivity in the solution, which can be acid or salt solution. So both ways it works. So first what it consists of, it consists of two metals which are having difference in the reactivity, and these metals are dipped in the solution either of acid or salt. So example, if I take two metals, I have magnesium, one metal, and I took copper as the second metal. So one of the metal, one side is made up of magnesium and another one is copper. And we connect them via a wire, and we can connect a lamp here because if electrical energy is there, so this lamp will light up just to identify, and it can be present in acid or the salt solution. Both ways it work. So sometimes we use the acid, sometimes we use the salt, but the working does not change. So example, if you are using a aqueous hydrochloric acid, so this is dipped in acid right now. Example can be any acid. If example hydrochloric acid, so it contains hydrogen ion, chloride ion, and all the acids are aqueous. Aqueous means they contain water as well. So H ion and OH ion. Now how it works, how the reaction occur, can you identify which metal is more reactive? Which metal here, magnesium or copper? Which is more reactive? Can you state which metal is more reactive? Magnesium, that's good. Because the reactivity series, we have potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen is there, copper, mercury, silver, gold, platinum. So when you check, you have magnesium and copper. So you can clearly see magnesium is more reactive. As we go down, the reactivity decreases. So first what happened? The more reactive metal lose electron and it turn into ion which enter the solution. So this is what happened. The more reactive metal will lose electron and it will turn into ion. So magnesium is more reactive metal here. So this magnesium will lose electron when magnesium belongs to group 2, so it will lose 2 electron. And what happened to those electron? The electron which magnesium lose, they will travel in the through the wire. So when the electrons are moving through the wire, as they passes through the lamp will light up. So the electron lost by the more reactive metal travel through the wires and transfer electrical energy. So this is what happened. The more reactive metal, like here magnesium is more reactive metal, that magnesium is losing electron. When it is losing electron, the electrons of the magnesium will travel. They passes through the lamp and they will transfer the energy to the lamp will light up. And these electrons will be there on the less reactive metal surface. So the electrons which move, why we use copper? We can use any other metal, but the idea is that it should be two metals which should have a difference in the reactivity. It can be any other metal. It's not necessary that we use copper. We can use any metal, but there should be a difference in the reactivity of the two metals. So the magnesium, which is having electrons, they travel through the wire, the lamp light up, and what happened to the electron? So the electrons which are there, the electrons on the surface of less reactive metal attract the positive ions from the electrolyte. So it will attract what? As these ions are being, these electrons are there, electrons are negative, so they will attract the positive ions. So what are the positive ions? We have magnesium, we have hydrogen. Because hydrogen is less reactive, so in the electrolyte, always the less reactive is discharged. So when hydrogen ions are there, at this point what happened? Hydrogen ions are there, they will take electron and it will turn into a hydrogen atom. But when two hydrogen ions are there, they will take two electron and it will form hydrogen gas. So when hydrogen gas is there, we will see bubbles. So we'll see bubbles on the less reactive electrode side and the size of the more reactive will decrease. This is how the cell which we are using works, that it is always consists of two electrodes. One is more reactive, another one is less reactive. So more reactive metal will lose electron, the electron will travel towards the less reactive metal surface, and these electrons attract the positive ions, so they collect the positive ions at the less reactive metal surface. Is it clear, the concept of a chemical cell, that how it works? So this is how, like even at you will see you're using a cell, a pencil cell, or which is also called a dry cell. So they all work on the same principle. They might have a salt solution or acid, but normally they are using a salt solution which are less corrosive as compared to acid. But the large batteries, you have seen the large batteries used in car, that also always consists of the same concept, that it is made up of two metals which are having a difference in the reactivity. If you want to produce more energy, if you want to produce more energy or more voltage, voltage means how much energy the charge carry, that's called voltage. So if you want to produce more voltage or energy by the cell, we should use two metals which have greater difference in the reactivity. So example, if I write a reactivity series, as this is about this is a reactivity series, what we have potassium, sodium, calcium, magnesium, aluminum, zinc, iron, lead, hydrogen, copper, mercury, silver, gold, and platinum will be there. Now example, we have two electrodes. One is made up of magnesium and another one is made up of zinc. And we use magnesium and say lead or copper. And they're connected by the wires. We can have a voltage here, a voltmeter. Voltmeter is a device which is used to measure the voltage. So we can use a voltmeter or we can use a lamp here. This one is the magnesium Mg. So when we compare, this is cell 1 and this is cell 2. Which cell will produce more voltage? Cell 1 or cell 2? So cell 2 will produce more voltage because cell 2 is having a greater difference in the metal reactivity compared to cell 1. More voltage is refers to how much energy the charges produce or energy carried by the charges. So if I say, if I compare, this will produce low voltage and this will produce high voltage. And how to work out the brightness, because if the voltage produced is low, then the lamp will be dim. Here voltage produced is high, so the lamp will be brighter. So using the brightness of the lamp or using the voltmeter, we can identify which cell will produce low voltage and which will produce high voltage. So it depends on the difference in the reactivity. Greater the difference in reactivity, greater the voltage produced by the cell. Is it clear, this concept, that how the voltage or energy depends on what factor the voltage or energy produced by the cell depends on? Now some questions related to this part. A chemical cell. That diagram shows a simple cell. So in the question, basically what happened? Which statement about the process occurring when the cell is in operation is correct? So cell is in operation means when the cell is working. We have to tell which one is correctly described when the cell is working. So when you check the options, when you sort out the working, how the cell is working, basically we have zinc electrode, we have copper electrode. Zinc is more reactive. So zinc atoms which are there, they will go inside the solution as a zinc ion. That is first thing what happened. And the electron will travel from zinc surface to copper surface. And because the zinc atom is changing into zinc ion, what happened to size here? The size will decrease. So which statement about the process occurring when the cell is operational? Copper ions are formed. Copper ions are not formed because copper is less reactive, it does not react. Electron travel through the solution. Electron never travel through the solution. Electron always move through the wires. So electron always move through a wire. So this cannot happen. Then the reaction zinc atom turn into a zinc ion. That's true. This is what happens. Zinc atom turn into. So at this zinc electrode, zinc is more reactive. It will turn into zinc ion by loss of electron. An zinc electrode increases the mass. It does not increase the mass. It decreases the mass. That's why C is the right answer. The diagram shows a simple cell. The diagram shows a simple cell. Which pair of a metal produce the largest voltage? So if you write the reactivity series, you have potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, mercury, silver, and platinum. So if we use the gray like iron and copper is here, magnesium and copper, this one, magnesium and zinc, this, and zinc and copper. So which is having the highest greatest difference, magnesium and copper, as you can see. That's why B is the right answer. Then another question, the diagram shows a simple cell. Which pair of a metal would electron will flow from metal X to metal Y? So metal X should be more reactive and metal Y should be less reactive because electron always move in the wire from more reactive to less reactive. And we have the reactivity series, which is potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, copper, mercury, silver, gold, platinum. So metal X should be more reactive. So if we select metal X, for if we check option A, metal X is copper and metal Y is iron. So as we can see, iron is more reactive, then electron flow is from Y to X, so it cannot be A. When we check copper and zinc, again the same idea. Zinc is more reactive than copper, so electron will move from zinc to copper, so it cannot be B. Iron and zinc, so when you check iron and zinc, this is iron Fe and zinc. So zinc is more reactive. Again, the electron move from zinc to iron, so it will be Y from X. But the last option, when we check, when we take metal X as zinc and metal Y as iron, so it will move from zinc to iron. That's why D is the right answer. Is it clear, this question? Anyone having a doubt? The reactivity series for a number of different metal is shown. The, the reactivity series with number of a metal is shown. The diagram shows different metal strips are there dipped in the electrolyte. Which pair of a metal produce the highest voltage? And I told you we want the greater difference in the reactivity to produce the highest voltage. So if we use one as more reactive, most reactive, and the other one is the least reactive, that will be the highest. So in that case, magnesium and platinum will give us the highest voltage. If you use copper and magnesium, so copper and magnesium, it won't be, because we want a greater difference in the reactivity. So this will be copper and magnesium, magnesium and zinc, silver and platinum. But the first one, second one, magnesium to platinum will have the greatest difference. That's why it will produce the highest voltage. The diagram shows a simple cell. Which two metal produce the highest reading? Which produce the highest reading on the voltmeter or highest voltage? So again, you work out from the reactivity, magnesium and, so first the reactivity is potassium, sodium, calcium, magnesium, aluminum, zinc, iron, lead, copper, uh, hydrogen is there, copper, mercury, gold, silver, platinum. So we have magnesium and we have copper, which will have the greatest difference. That's why it will produce the highest voltage. Yeah, that's a repeated question. Another similar question, which metal combination produce the highest voltage? Which metal combination produce the highest voltage? Again, the reactive, so you can clearly see the reactivity series is very important for this part. So copper, iron and copper, zinc and copper, copper will produce 0 volt because same is it. Magnesium and copper will produce a higher, that's why D is the right answer. So this was about the chemical cell. Now what is the difference between the chemical cell and electrolytic cell when we compare the difference? So in electrolytic cell, we pass the current to break down the substance into ions which move towards their respective electrodes. This is what happened in electrolytic cell. But what happened in chemical cell? The current is produced or the voltage is produced, the movement of the charges occur due to difference in the reactivity of two metals. So two metals have difference in the reactivity. So when we draw a chemical cell, the electrolytic cell, so we draw always a battery or a cell with positive and negative terminal. There will be anode, there will be cathode, and the solution will be the electrolyte. But in a chemical cell, we can draw a voltmeter or a bulb. Then we use two metals which are having difference in the reactivity and we place them in the solution. That's the difference. Here we can use any type of metal in, but in this case it will only work with two different metals. If even if two identical metals are there, it won't be correct. It won't work. Is it clear the difference between the electrolytic? So basically electrolytic cell is converting electrical energy to chemical, and whereas chemical cell is converting chemical energy to electrical. What is the direction of electron flow? Like if I say this is a more reactive metal and this is a less reactive, so electron will flow from more reactive to less reactive. But for electrolytic cell, electron will move out from the negative terminal and they're attracted towards the positive terminal. This is the movement of electron. Is it clear? The difference in electrolytic and chemical cell? Any doubt or a question related to this part?